Alright, hello everybody. This is going to be a review of the practice midterm number 2. I'm going to go over not all the questions, but a few of them, and to save some time. And yeah, so let's just jump right into it. I gotta share my screen first. Here we go. Alright, number 9. We start with, we need to find the probability that 3 babies in a row are going to be the same sex, given that the likelihood of being a girl or a boy is both 0.5. So you would think in your head, you can just say, okay, 0.5 times 0.5 times 0.5, 3 in a row, and that gives you 0.125, right? But that fails to factor in the consideration that you could have 3 boys. Oh, didn't mean to do that. Get 3 boys, or you could have 3 girls. And considering that both of these probabilities is 0.125, this is in total going to equal 0.25. Simple as that. Enter C. Okay. Question number 12. Did not mean to give you all that. Okay, I've done this like 4 times and I get lost halfway through and I have to restart. Okay, so this question, right? Event A occurs given that we have a probability of 0.4. All right, so probability of A is 0.4. Okay. It also tells us the probability of A given B is equal to 0.5. It also tells us that the probability of A, given that we do not get B, that's not proper notation, but just ignore it, equals 0.2. All right. Now, these are the pieces of information it gives us. What we need from this is find the probability that B occurs given that A occurs. Right? So the way you're going to solve this question is you've got to go through each one of these things it gives you, and you've got to break it down into how you derive the probability. Like, so to say, for example, probability of A and B, given B, not given G, given B, right, is equal to the probability of A and B all over the probability of B. Okay, and it tells us this is equal to 0.5. Right, so we can do the same thing for probability of A not given B. So probability of A not B is equal to probability of A and not B all over probability of not B. Okay, and so this is equal to 0.2. Right, so we have these 2 functions now, right? And now we need to look, okay, where's some more similarities that we have here, right? What are some more similarities? Well, let's look at our final answer. How does this break down? This is going to break down into probability of A and B all over probability of A, which it gives us. It gives us probability of A. So really what we need to find is the probability of A and B. Right, so how do we go about finding this? Well, what we're going to do is we're going to look for some more connections between the stuff that we have here. So anytime you see something that's like not B or that's like not B or B, right? So you have something that gives us the probability that B occurs, right? Or it doesn't, but in theory, if we had the probability that B occurs, and we also had the probability that B does not occur, right? The 2 of those combined is going to be 1, right? So probability of B plus probability of not B is equal to 1, right? That's a crucial assumption for this, right? And that's how we're going to translate some of this into using A given B and probability of B instead of not B and probability of not B. All right. The next assumption, we are going to also use the whole not thing, right? So the probability of A and B, right, which we're trying to find, probability of A and B, plus the probability of A and not B is just going to be the probability of A. And you can find this by, if you just break this down, so probability of A and B is equal to the probability of A times the probability of B. And if you're going to add this to probability of A and not B, you're going to add that to probability of A, probability of A, capitalize that, probability of A, times the probability of not B. Okay. And what you can do is you can just factor out probability of A times the probability of B plus probability of not B, which we know this, given this, is equal to 1. So probability of A times 1, which is equal to probability of A. Okay, so that's what we're going to use for this. And probability of A, we'll go ahead and write it down, equals 0.4. Okay, so I'm just going to delete this, or erase this, because we don't really need this anymore. It's just taking up space. So now, the first step, right? We're going to look at this function, and we're going to translate all this so that we get rid of the not B's, because we don't want that. We don't want that. So if we look at this, right, to get rid of this, let's use this assumption, right? And let's say, okay, we have, or let's look at this one, right? With the assumption, say, okay, we have this, that's here. Solve for this, and you're going to get 0.4, because it equals probability of A, which is 0.4, 0.4 minus probability of A and B. And that comes from this right here, okay? Over probability of not B, right? We want to find the probability of B and use that instead. So we can just do 1 minus the probability of B. Okay, and this is our first equation. And what we're going to do is we got to figure out what we want to solve this for. Now, you can't go out and say, all right, let's just go ahead and solve for probability of A and B, so that way we can plug it into here and be done. You can't do that, right? You need to solve. You still have to factor this probability that it gives you into all this, what you're doing. So what we can do is we can solve for, we're going to solve for the probability of A and B in this question, but then we're going to plug it in to this, right? So let's do that. So we're going to solve this question, which is just 0.4 minus probability of A and B over 1 minus probability of B, which is equal to 0.2. And we're going to do 0.4 minus probability of A and B is equal to 0.2 times 1 minus probability of B. And then we're just going to subtract 0.4, so minus 0.4. And so then we're just going to multiply the whole thing by -1 to get rid of, because this negative tripped me up first. So multiply this whole thing by -1. Probability of A and B is equal to -0.2 times 1 minus probability of B plus 0.4. So if you want to simplify this, we can just go ahead and distribute. So it's going to be -0.2 plus 0.2 probability of B plus 0.4, and that cancels out, and that cancels out, and we just have plus 0.2. So we have 0.2 plus 0.2 probability of B is equal to probability of A and B. So we found this, right? This is now a fact that we have, but it doesn't yet include this. So we're going to plug what we just found into this equation. So we're going to plug 0.2 plus 0.2 probability of B divide that by a probability of B, and that is equal to 0.5. Okay. So let's solve for probability of B now. And what we're going to do is we're going to do 0.2 plus 0.2 probability of B is equal to 0.5 probability of B. And then we are just going to subtract that. So now we have 0.2 is equal to 0.3 probability of B. Divide this by 0.3, divide by 0.3, and we have probability of B is equal to 2 over 3. Right. So now what we're going to do is we're actually going to take this and we're going to plug this back into the same equation that we just solved for. So we're going to plug this back into here, and it is going to give us, and we're going to solve for probability of A and B, which is what we need here. So if you're asking, well, if you know that probability of A and B just equals probability of A times probability of B, you can't just plug the probability of B into there and then plug it in up here. For some reason it doesn't work. I don't know why, I haven't figured it out, but it just doesn't. So you're going to plug it back into here and just solve directly for this. Go to office hours if you can't figure it out. I don't really care at this point. So what we're going to do is we now have 2/3. We have the probability, we have the probability of A and B over 2/3 is equal to 0.5. Solve 2/3 times 0.5 is just 1/3. Okay, so probability of A and B is 1/3. Okay, so to finish this out, probability of B given A is equal to 1/3 over probability of A, which is 0.4, which is 2/5, which is equal to 5/6. And that is your answer. 5/6. Okay. All right, now that I'm finally done with that question, we will move on to 13. And 13, well, let's just take this out. So 13, which of the following statements is correct, given that the events A and B have non-zero probabilities? So probability of A is greater than 0, probability of B is also greater than 0. So the answer choices kind of guide you in the right direction. So it talks about mutually exclusive events and then independent events. So to have an event that's mutually exclusive, right, which means they cannot occur at the same time, probability that A and B occurs at the same time is going to be equal to 0. Right? So this, in this case, can not apply. So it can't be mutually exclusive, because that would mean that one of these probabilities would have to be 0, right? And they're not. Both of them are not 0. So we know it can't be mutually exclusive. Gone is that. If we want it to be independent, we just need to prove that, I mean all that is just a probability of A and B is equal to probability of times probability of, like that's all we need to know if something is independent. So you don't even need to do this. You just need to look at this and say mutually exclusive, probability of A and B is 0, right? It can't be that, so it can't be independent, mutually exclusive. Both of them can't be. That may not be the best explanation, but that's just how I think about it. 14 the weight of a medium-sized tomato selected at random from a bin at the local supermarket is a random variable with a mean of 10 ounces and a standard deviation of 1 ounce. 2 tomatoes from the bin. The difference in the weights of the 2 tomatoes selected, the weight of the first tomato minus the weight of the second tomato, is a random variable with a standard deviation in ounces of what? Excuse me. So what this is asking is the weight of the first tomato. Let's just say tomato 1 is going to be, let's just make that X, all right? And then tomato 2 is going to be Y, all right? So what this wants to know is the difference in the weights of the 2 tomatoes selected is a random variable with a standard deviation of what, right? So you can't just say, all right, well, let's take the standard deviation of the first one, which is just 1, and subtract the standard deviation of the second one, which is just 1, and that's going to give us 0. That is an answer choice, but it's not correct because you can't compare standard deviations, but what you can compare is the variance in the 2. And so what that looks like is you're just going to find the variance, right, and then of x minus y, which is equal to, you would think you just do the variance of x minus the variance of y, and you solve. Well, that's not actually correct. So something, independence, right? This is assuming that these events are independent, and when you have variance and when you're like taking the difference of variances, it actually turns out that when you subtract the variances, you're actually just going to add them, because when you're like, I'm not doing the proof for that. There's a Khan Academy video that does it, but it works out, and I'll attach it. I'll put it in the bio so you can, or in the description so you can see it. But this for now, we're going to take this as fact with independent events. This is how you can calculate this. So the variance of 1 is just going to be 1 squared, which is 1. And then the variance of y, tomato 2, is just going to be 1 squared, which is 1, plus 1, which is equal to 2. But this is the variance. So your variance of x minus y is equal to 2. But it's asking the standard deviation. So you need to take the square root of this. And the root of 2, square root of 2, is equal to 1.41. And that is your answer for this. So take away from this question, remember, go look up this proof if you want to learn that. But then also know that you can't compare standard deviations of random variables, but you can compare variances. There's that. And this question kind of ties into it. This is a difficult one too. And I guess let's go ahead and go over this one. Homework. So there is something that you have to do when you do not have independent variables, right? It's not telling you they're independent, and it's giving you this correlation value here that you need to somehow factor into this. And there's all kinds of stuff with like covariance and stuff. I can't remember, I think it was lecture 13, page something in the teens, I don't know, lecture 13, he actually goes over and he gives us an equation for this that does not involve any of the upper level like covariance and that kind of stuff. So basically the variance of, so this is what it's asking right here. It's asking the variance of 2x minus 3y. So when you have the variance of a variable of x plus a variable of y, right, your equation is just going to be that a value squared times the variance of x, right, plus that b value squared times the variance of y. And I may not have enough room for this. Let's move this over a little bit. Plus 2 times a times b times your correlation value of p, or not p, there's a word for that, but I don't know what it is, times your standard deviation of x times your standard deviation of y. That's a whole lot, and I think it's kind of crazy, but it is what it is. So, in the context of this equation, here's what this is: the standard deviation, or the variance of 2x plus 3y is equal to 4, because 2 times 2 is 4. 4 times the variance of x, which is 7.5, plus our b value squared, which is, in this case, 3. 3 times 3 is 9, times our variance of y, which is 6, plus 2 times our a value, which is 2, times our b value, which is 3, times our correlation value, which is 0.6, times our standard deviation of x, not the variance. So you need to take the square root of 7.5 times the square root of 6, because these are standard deviations, not a variance, and then just do all that, and you come up with a number that is close to 132, and that is your answer in this case. Did I circle the last answer? I did. Okay. There's 8. Sorry if my stuffy nose, I have allergies. That's how you do this question. The next question, 15, is pretty easy. I actually haven't worked this one out yet. So all you're going to do, it wants to find the probability of between 1 and 2. So that's just between here and here. And all you're going to do is just find this area. So pretty easy. This is 0.5. So 0.5, and this is 1.5. So it's just 0.5 over 2, which is just 0.25, is your area for this. That's your answer for that. And that is all. So yeah, wish you guys the best of luck. Go to his office hours at like 7 o'clock or whatever it is on Monday tonight, and good luck.